Hey guys, let's talk about osmosis real quick. First of all, osmosis is just the movement or diffusion of water from where there's a lot of water to where there's not much water. As you can see in these diagrams right here, it's kind of flip-flop backwards. These little dots represent the solids, the things dissolved in the solution or the environment outside the cell or inside the cell. As you can see here, we've got lots of solute outside the cell compared to inside the cell. So by comparison, that means there's a lot of water in the cell compared to outside. So osmosis would drive the water out. Osmotic pressure would, in order to balance out that difference in the solute concentration. Over here on the other side, there's a lot of solute in here. That means by comparison, there's not much water in here compared to out here. So the water is going to rush in by osmotic pressure. The one in the middle, it's about equal, so they're going to move in and out equally. All right. Now, biologists give these different types of environments names. The ones where there's a lot of solute outside of the environment compared to the inside is called hypertonic. See if that catches up. Hypertonic solution. All right. And again, we're talking about the environment out here, outside the cell. If there's more solute inside than there is outside, in other words, there's less solute, it's hypotonic. The suffix tonic comes from the word tonos, which means strength of. So there's a very low strength or low amount of solute outside the cell compared to inside. Over here, there's a very high amount. Hyper means high or above, more than a high strength solution environment outside the cell compared to inside. This right here is equal. It's considered an isotonic solution. And this is the environment we want our cells to be in, because that allows water to flow freely back and forth as we need it. Plants, on the other hand, like to be over here in this hypertonic state. Can't think of too many things like to be in a hypertonic state, but here's a concept you understand. It's all relative. If I took this cell and I put it over here in this environment, well, the concentration of solutes inside and outside would be about the same, so it wouldn't be hypertonic, it'd be about isotonic. If I took this cell, which has very little solute, and put it over here in this environment, which also has very little solute, now they would be isotonic to one another. So as far as hypertonic, isotonic, hypotonic, it's all relative. It all depends on how much solution's inside the cell compared to outside the cell, and now determined. One of the easiest ways to remember which way water is going to go is solute sucks. You can see it right up here at the very top. If you can remember that, it's fairly simple to remember which way water is going to go as a cell is placed in these different environments. Let's check out hypertonic. If a cell is in a hypertonic environment, that means there's more solute outside compared to inside the cell. Solute sucks. Well, the solute out here is going to suck or pull the water out, causing that cell to dehydrate, shrivel up, and eventually die if it's not restored. In an isotonic solution, solute sucks. Well, they're equal on both sides, so water's going to move in both directions equally. The cell doesn't really change much. It's just going to be pretty fine and dandy. Over here, hypotonic, there's less out here, more in here, so there's more solute. Solute sucks. So the solute sucks or pulls actually the water in, causing the cell to get larger. And if there is no cell wall, and the pressure exceeds the tensile strength of the cell membrane, it can cause the cell to rupture. Again, that's not good for our cells. If our cells are in a hypotonic state, they can rupture or lyse, they call it, and as you can see, it spill out all the contents and die. So again, quick rundown on what osmosis is and how these different environments can affect cells. Remember, hypertonic, high amounts, all that solute out here is going to pull the water out because solute sucks. Isotonic, equal amounts outside compared to inside. It's going to move in and out equally, causing relatively no change in the cell. And a hypotonic environment out here, it means there's less low amount of solute compared to inside. So this high amount of solute inside is going to pull the water in, causing the cell to swell, and if it's too strong of pressure, it could cause it to burst and rupture. Hope this helps, and it's going to help you on your case study analysis of Osmosis is Serious Business, parts 1 and 2. I hope you guys have a great day and be awesome.